All right, so we've done some work with similar triangles. We've solved proportions. Let's see some real-world uses for that skill today. So applications using similar triangles is the subject matter of lesson 65. Trevor took big steps to find the length of the shadow of the big pine tree in front of the school. He estimated that the shadow was 16 yards long, which is about 48 feet. He also stepped off the shadow cast by the two-story school building and estimated that its shadow was 18 feet long. Trevor thinks the building is 24 feet tall. About how many feet tall is the pine tree? So let's look at this situation here. Got a pine tree. You guys all know what an artist I am. That's casting a shadow. And we've got a school building. Two-story school building casting a shadow. Now the shadow of the pine tree is 16 yards, but we're going to go ahead and do it in feet since all the other measurements are in feet. So we'll say that the shadow of the pine tree is 48 feet long, and the shadow of the school building is 18 feet long. The height of the school building is 24 feet high, and we don't know the height of the pine tree, but we're trying to figure that out. Now what we've got here is two right triangles that happen to be similar. And I know they're similar because they're right triangles, first of all. And also the sun that is creating the shadow is hitting both the tree and the school building at the same angle. Almost exactly the same angle. So we've created similar right triangles. So we can set up a proportion. We can say that the height of the pine tree, x, is to the height or the length of its shadow as the height of the school building is to the length of its shadow. From here, this proportion, you guys are very good at solving proportions. I'm definitely not worried about you once you get to this point. It's just a matter of setting it up. But we'll do cross products. 18 times x is equal to 48 times 24, and then divide both sides by 18. So the height of the tree is approximately 64 feet high. Okay. Holding a ruler upright at arm's distance, 24 inches is about arm's distance for Ronnie. Ronnie aligned the bottom of the ruler with a mark on the utility pole that was about 5 feet above the ground. He saw that the top of the pole aligned with the 6-inch mark on the ruler. Then he took 40 long strides to reach the pole. If each stride was about 1 yard, 3 feet, then the top of the pole is about how many feet high. So I've done a drawing here. Here's Ronnie, good-looking guy, shaved head like Mr. Kaczynski. He's holding out this ruler at arm's length. We could probably put a couple distances in here. We know that he's 40 yards or 120 feet away from the pole. We also know that this ruler he's holding up is 2 feet, 24 inches away from him. So what do we have going here? What we've got is similar triangles again. Okay. We've got a similar triangle created by the distance that and he's holding the ruler from himself, 24 inches, with the height of the ruler, 6 inches. Creates a right triangle. And we've also got a triangle here where Ronnie is 120 feet. Remember, he said 40-yard long strides from the telephone pole, and the height of the telephone pole that we're trying to figure out. That creates a triangle. Now, these are similar triangles, number one, because they're both right triangles, and I know this angle down here in the lower left is the same because that's Ronnie's line of sight through the 6-inch mark of the ruler and to the top of the telephone pole. So we can set up a proportion to find this height of the telephone pole. We'll see this 30 feet. Now some might say, Mr. Kaczynski, you got to slow down here, sir, because you've got your smaller triangle in inches and your bigger triangle in feet. It really doesn't matter. I'll prove it to you. If we say that 6 inches is half a foot or 0.5 of a foot, and we say 24 inches is 2 feet, and then we redo this proportion, 0.5 over 2 equals x over 120, we're still going to get 30 feet. But one other key thing here, and I keep telling you guys, you got to answer the question that is asked of you. The question is, how tall is the telephone pole or this utility pole? It's not 30 feet tall. Okay, it's 30 feet from, you can see where I'm pointing over here, from this mark up to the top. Remember, his line of sight was with a point that was 5 feet above ground level. So we actually have to add 5 feet to that 30 feet. So the height of the pole in total is 35 feet. Okay, a little bit of work with similar triangles today, and we'll continue to work on this as days go on. We'll get better at it. We'll master it. Good luck, and I'll see you tomorrow.